Now let's begin with the next unit of our syllabus, unit number 8, redox reactions. Okay. Now the word redox is made up of two things, reduction plus oxidation. Okay. Reduction plus oxidation together is known as redox. So what are redox reactions? Redox reactions are those in which the reduction and oxidation occur simultaneously. Simultaneously means together. Okay, so those reactions in which both the processes are occurring together, they are known as redox reactions. So in this chapter, we have to discuss about redox reaction. Now first we'll discuss the concept of reduction, concept of oxidation. What is the meaning of reduction? What is the meaning of oxidation? Then how we can find out whether reduction is taking place or oxidation is taking place? What is reducing agent? What is oxidizing agent? Then finally we have one important thing in this chapter, that is balancing of the equation. Okay, in 10th class also you have done balancing by hit and trial method. Now in 11th class we have balancing of ionic equations, means those equations which involve ions. So basically this chapter deals with the balancing part of ionic equation. Okay, but before starting with the balancing part, first we'll discuss the basic concept in this chapter, that is the meaning of reduction and oxidation. Now the first is oxidation reaction. What is the meaning of oxidation? Oxidation means addition of oxygen or any other electronegative element also. For example, in any reaction, if chlorine is added, fluorine is added, then it is considered equivalent to oxygen only. So addition of oxygen, or we can write any electronegative element, or removal of hydrogen is known as oxidation. So there are few reactions here which can explain the meaning of oxidation. Now you can see C plus O2 gives CO2. Now here oxygen is added. Mg plus O2 gives MgO. Here again oxygen is added. So these are oxidation reactions. Likewise, see this reaction. Now from this H2S, you can see H2S is converted to H2O. So what is, and plus sulfur is converted to S. So what is done here? Okay, from H2S, hydrogen is removed. Okay, because H2S is changing to S. So hydrogen is removed. It means this is also considered as oxidation reaction. Now, what is reduction? Reduction is either addition of hydrogen or removal of oxygen. Now, these reactions are there. You can see here hydrogen is added. Cl2 plus H2 gives 2HCl. Here also hydrogen is added and we get HBr. Or there is removal of oxygen and CuO plus H2. Now from copper oxide, oxygen is removed, so we get copper. Okay, so this is how oxidation and reduction occur. Now oxidation and reduction reactions are complementary. They always go side by side. It is not possible that only oxidation is taking place or only reduction is taking place. If one substance is oxidized, simultaneously the another substance is reduced. For example, oxidation means addition of oxygen. So who is supplying oxygen? The other substance which is supplying oxygen. It is oxidizing other, but itself it is reduced. So oxidation and reduction never go alone. They go side by side. That's why the reaction is known as redox reaction. Okay, so we cannot say that this particular reaction is oxidation or this particular reaction is reduction. But what is the most important thing? That the reaction is redox reaction. Now two reactions I am taking here. Now in this reaction, your H2S is changing to S. So here you can see that hydrogen is removed. There is removal of hydrogen. And O2 is changed to H2O, means there is addition of hydrogen. So this process is reduction and this process is oxidation. Okay, now what is the purpose of H2S? H2S is losing hydrogen, but this hydrogen is taken up by oxygen. Okay, so this is redox reaction. Likewise, it is changed to Fe. Now there is removal of oxygen and here there is addition of oxygen. So removal of oxygen is reduction and addition of oxygen is oxidation. Okay, so oxidation and reduction always take place simultaneously. They always take place side by side. Now next is oxidizing agent or oxidant and reducing agent or reductant. What is oxidizing agent? The substance which oxidizes others, means which will provide oxygen, which will remove hydrogen. That is known as oxidizing agent, and itself the oxidizing agent is reduced. Likewise, the substance which reduces others but itself is oxidized, that is known as reducing agent. Now we'll take one example here. Suppose in this reaction, okay, now in this reaction Fe2O3 is changed to Fe, okay, and Al is changed to Al2O3. So what this Fe2O3 is doing, okay, it is providing the oxygen to aluminium, so it is undergoing reduction. Okay, now the substance which undergo reduction is known as oxidizing agent. So what is my oxidizing agent? Fe2O3. Aluminium is oxidized, so here oxidation is taking place, and the substance which undergoes oxidation is reducing agent. So what is the reducing agent? Here your aluminium is reducing agent. So the substance which undergoes reduction is oxidizing agent, and the substance which undergoes oxidation is reducing agent. Now we'll take two more examples. Now H2S plus Cl2 gives 2HCl plus S. H2S is changed to S. Now hydrogen is removed, so this process is oxidation. Now Cl2 is changed to HCl. Now in this hydrogen is added, so this process is reduction. The substance undergoing oxidation is known as reducing agent. So reducing agent will be your H2S, and the substance undergoing reduction is your oxidizing agent. So if any reaction is given to us, we can predict four things: oxidation, reduction, oxidizing agent and reducing agent. Okay. Next is electronic concept of oxidation and reduction. If any simple equation is given to me, I can find out oxidation and reduction in terms of loss of hydrogen, addition of oxygen, addition of hydrogen or loss of oxygen. But suppose if any ionic equation is given to me, suppose my reaction is this. Now this equation involves ions. Then how to find out that this is oxidation or this is reduction? So now we have to discuss the electronic concept of oxidation and reduction. That is oxidation and reduction in terms of charge transfer or in terms of electrons. Now oxidation means loss of electrons. Okay, so whenever any atom or group of atom loses electron, this process is known as oxidation. Suppose we have sodium, it is changed to Na plus electron. This process is oxidation. Suppose we have Fe2 plus, it changes to Fe3 plus by losing one electron. This is oxidation. The next is, suppose we have Sn2 plus, it changes to Sn4 plus 2 electrons. This process is oxidation. Okay, so oxidation means loss of electron, and when the electrons are lost, okay, the positive charge increases. So increase in positive charge is oxidation. Sometimes the electrons are lost. Sometimes the electrons are lost from the negative ion also. Suppose Cl minus is there, it changes to Cl by losing one electron. Suppose S2 minus is there, it loses one electron and changes to S minus. So what happens because of this loss of electron? There is decrease in negative charge. So when the electron is lost, either the positive charge increases or negative charge decreases. So reduction means gain of electron. Suppose Cl is gaining one electron, it is changing to Cl minus. O minus is gaining one electron, it is changing to O2 minus. So because of this, there is increase in negative charge. Okay, that is here -1 to -2. Likewise, suppose Fe3 plus is there, it is gaining one electron, so it will change to Fe2 plus. Or we have Sn4 plus, it will gain 2 electron and it will change to Sn2 plus. So there is decrease in positive charge. Okay. So if the positive charge increases or negative charge decreases, it is oxidation. But if vice versa is there, then it is reduction. So if any ionic equation is given to me, I can easily find out which is oxidation, which is reduction, which is oxidizing agent, and which is reducing agent. So now oxidation and reduction as electron transfer. So how to find out oxidation and reduction if the ionic equation is given to us? So suppose this is the equation, Zn plus Cu2 plus gives Zn2 plus Cu. Now here the charge on zinc is 0, here the charge on zinc is plus 2, here it is plus 2 and here it is 0. 0 to plus 2, there is increase in the positive charge or overall increase in the charge, it is oxidation. And plus 2 to 0, it is decrease in charge, so it is reduction. Okay, likewise, suppose if the equation is this. So we'll find out the charge. Here the charge on Br is 2Br is there. So it is minus 2, it is 0, it is 0 and it is minus 2. So minus 2 to 0. Okay, now what is happening? Minus 2 to 0. If we see the number line, 0 is here and minus 2 is here, means the charge is increasing. So if the charge increases, it is oxidation. And 0 to minus 2, since the charge decreases, it is reduction. So whenever the charge increases, means we are moving to the right side of number line, it is oxidation, and if we are moving to the left side of number line, it is always reduction. So now we have few definitions here. So what is redox reaction? The reaction in which oxidation and reduction occur simultaneously. What is oxidation? It means loss of electron or increase in charge. Means we are moving to right side of number line. What is reduction? It is gain of electron or decrease in charge. Means we are moving from towards the left side of number line. Oxidizing agent which oxidizes others, itself it is reduced, so it will accept electron. The substance which is accepting electron is oxidizing agent. And what is reducing agent? Which reduces others but itself is oxidized, so it will lose electron. So these are the few definitions or few concepts regarding the redox reaction. Okay, now we'll discuss types of redox reactions. Now there are two types of redox reactions. The first is direct. Direct means the oxidation and reduction will take place in a single container. Okay, and we have a single container in which both the oxidation and reductions will occur. The oxidizing agent is also placed here, the reducing agent is also placed here, and both the processes take place simultaneously. But in indirect redox reaction, we have two different containers, and here oxidation will occur in one container and reduction will occur in one container. Okay, so first of all we'll discuss direct redox reaction. Now as an example of direct redox reaction, what we'll do, we'll take a container and we'll fill solution of copper sulfate here. Now copper sulfate solution is, this is aqueous copper sulfate, it is blue in color, and we'll put a zinc rod or zinc strip in it. Okay, so a zinc strip is put in it, or zinc rod is there. Okay, now we'll keep it for some time, and after some time what we'll find that zinc starts losing its weight, means the zinc rod is dissolving. We'll find that the zinc rod loses its weight gradually, and we'll also find that the copper metal either deposits on zinc plate or it can settle down also. And what will happen because of this? Color of copper sulfate fades. So we'll find two things here. First, the zinc rod will become thin. It will become gradually thin, and the copper metal starts depositing at the bottom of the container or on the zinc plate itself. And as a result of this, the color of copper sulfate fades away. Now, what is the reason behind this? Because in this, a redox reaction is taking place. So zinc is placed in copper sulfate. So what will happen? Now this is a type of displacement reaction. Zinc is more reactive, so it will change to ZnSO4 plus copper is changed to copper. So what is happening in this equation? So I was having zinc rod, zinc metal. Now copper sulfate means Cu2 plus is involved. Now it changes to, now zinc rod loses its weight because it is changed to ZnSO4. So it will change to Zn2 plus, and CuSO4 is changed to copper. So this process is oxidation and this process is reduction. So as an example of direct redox reaction, we can see that zinc and copper sulfate, they show the best example. Okay, so both oxidation and reduction are taking place in the single container. Zinc is losing electron, it is changing to Zn2 plus. These ions go into the solution and form ZnSO4. Cu2 plus ions from the solution accept those electrons, because whatever electron zinc is losing, these electrons are accepted by copper, Cu2 plus, and these Cu2 plus will change to copper. Okay, so this is how your redox reaction occur. Now, as an example of indirect redox reaction. Now, as an example of indirect redox reaction, we have electrochemical cell. Okay, the cells which we use in our daily life, day-to-day life. Okay, these are also known as galvanic cells. They convert chemical energy to electrical energy. Now, there two separate containers are there. Okay, so suppose in this container zinc rod is there. So here I will fill zinc sulfate solution. Here copper rod is there. Here I will fill copper sulfate solution. These two rods are connected. Okay, here voltmeter is there. This is salt bridge. So in this indirect redox reaction occurs. So here also the same reaction will take place. But here on the left side oxidation will occur and on the right side reduction will occur. On the left side Zn will change to Zn2 plus 2 electron. So zinc rod will lose weight. Now these two electrons are accepted by Cu2 plus. Cu2 plus means from copper sulfate and will change to copper. So here also the redox reaction is taking place, same reaction is taking place. Okay, but the two different containers are there. Okay, now electrochemical cells we are going to discuss further in class 12th. But in electrochemical cells or galvanic cells, which we use in our day-to-day life, in toys, in mobiles, in remotes, they are all having redox reactions only. Now the next topic in this chapter is oxidation number. So we have completed the introduction part of redox reaction. Now we are moving to the main part of this chapter, oxidation number. It is also known as oxidation state. Now what is the meaning of oxidation state? It means the charge which an atom of the element appears to have when present in combined state with other atoms. Okay, so what is the meaning of oxidation state? Basically, suppose if I write Zn. Now what is the charge on Zn here? It is 0 because it is neutral, it is elemental state. But suppose zinc is making a compound ZnO. Then what charge this zinc is having? That is known as oxidation number. So the charge which an atom of the element appears to have when present in the combined state with the other atoms. Okay, suppose if I write the reaction like this. Okay, now suppose if it is asked that how will you find out oxidation and reduction in terms of charge, then I know that the charge on zinc here is 0, here hydrogen is 0 because these two are elements. But what is the charge on sulfur here, or what is the charge on zinc here? How to find out? So when the element is present in the combined form, means when it is making compound, how to identify its charge? That is known as oxidation number. So now we are learning to find out the oxidation number of any element, the charge of any element, and after knowing the charge we can find out that now this is oxidation and now this is reduction. The first rule is the oxidation number of any element in its free or elementary state is 0. For example, sodium, copper, zinc, H2, Cl2, O2, N2. Now these are all the elemental forms. P4, S8, these are allotropes. So if the atom is present in the elemental state, then what is the charge on that element? It is 0. So what is the charge on hydrogen here? 0. What is the charge on zinc here? 0. What is the charge on sulfur here? 0. What is the charge on nitrogen here? 0. So when the element is present in elemental state, its charge is 0. Okay. The second rule is, now the second rule is oxidation number of any element in ion form. So if the element is present in the ion form is same as charge on it. Suppose if I write Zn2 plus. Now zinc here is not elemental, it is in ionic form. So what is the oxidation state? It is +2. Suppose if I write Cl minus. Now here it is not the elemental state. So what is the charge? -1. So if monoatomic ion is there, monoatomic means single atom is there. So if the element is present in monoatomic ion form, what is the oxidation state of element? That is equal to charge on that particular element. The third rule is oxidation number of hydrogen in its compounds. So when the hydrogen is making compounds, the oxidation number is always +1. But some exceptions are there. Now, what are the exceptions? In the compounds with metals, for example, LiH, NaH, MgH2. Now here it is more metallic as compared to hydrogen. What is the oxidation number of hydrogen? It is -1. Okay, so in the compounds with alkali metals, now lithium, sodium, magnesium, they are alkali and alkaline earth metals. Okay, so when the hydrogen is making compound with first and second group members, its charge is -1, otherwise always it is +1. Likewise, oxidation number of oxygen in its compounds is -2. Now few exceptions are there, except peroxides. Now suppose we have hydrogen peroxide. So what is the charge on oxygen here? It is -1. Now suppose we have OF2. What is the charge on oxygen? It is +2. And likewise, if we have O2F2, what is the charge on oxygen? It is +1. So oxygen always has the charge of -2, but few exceptions are there. Peroxides, the charge on oxygen is -1. In OF2, it is +2 because fluorine is more electronegative than oxygen. Likewise, in O2F2, it is +1. Okay. The next is fluorine. It always has -1 oxidation state because fluorine is the most electronegative element in the periodic table. Okay. Other halogens also show -1 oxidation state when bonded to other element. Okay, so fluorine will always show -1 oxidation state. The other halogens will always show -1, but sometimes it is possible that suppose I have the compound ClF. Okay, suppose my compound is ClF now. Now it is -1, so it is +1. So fluorine can never show positive oxidation state, but sometimes other halogens can show positive oxidation state depending on the element to which they are bonded. Okay, so these are few rules regarding finding out the oxidation number. Okay, now we'll take some examples that how to find out the oxidation number of any element in the compound form. The question is, calculate the oxidation number of underlined atom. Suppose the first question is CO2, the second is H2S, the third is MnO4 minus, and the fourth is, okay. Now suppose I have to find out the oxidation number or oxidation state of underlined atom. So what I will do, suppose the first example which I am taking is CO2. I have to find out the oxidation number of carbon. So I will put this as X. Now I will add all the charges because as a whole the molecule is neutral, means the total charge is always equal to 0. So carbon is X. Now how many oxygen atoms are there? 2. What is the charge on one oxygen? It is -2. So oxygen is 2 into minus 2, and what is overall? It is 0. X minus 4 equal to 0. So what is the charge on carbon? It is plus 4. This is the way to find out the oxidation number. We'll take the second example. Suppose my question is H2S. Now hydrogen has a charge of plus 1, so 2 into plus 1. Now sulfur is X, overall 0. So what is X? It is minus 2. So what is the charge on sulfur? It is minus 2. The third is MnO4 minus. So I will find X. So my X is manganese. Total number of oxygen atoms 4 multiplied by minus 2 equal to minus 1. So X equal to plus 7. Likewise, Cr2O7 2 minus. So I have to find out of chromium. Now 2 Cr is there. So I will put 2x because the number of chromium atoms are not 1, it is 2. So I will put 2x here. Okay, I am writing here. So it is 2x plus 7 into minus 2 equal to minus 2, because now the total charge is not 0. It is equal to minus 2. 2x minus 14 equal to minus 2, or x equal to plus 6. So this is how we can find out the oxidation number of any element when it is present in the combined form. Now few more examples are there. So fifth is Na2S2O3. So I have to find out the oxidation state of sulfur here. I know the oxidation state of oxygen, but I don't know about sodium. Now I will use my sense that sodium belongs to first group of periodic table, and whatever first group elements are, they have plus 1 oxidation state. So sodium has plus 1 charge, so it is 2 into plus 1 plus 2x plus 3 into minus 2, because oxygen is 3 and minus 2. In total it is 0. So plus 2 plus 2x minus 6 equal to 0. So what is x here? If I find out, now x is plus 2. Okay, because 2x minus 4 is 0, 2x is 4, so x is plus 2. The second is S2O7 2 minus. So 2x plus oxygen is 7, 7 into minus 2 equal to minus 2. Okay, so here x equal to plus 6. Likewise, CH4, carbon is x, hydrogen is having plus 1 charge. It is 0 now because it is a molecule, neutral molecule, so x equal to minus 4. Okay, now here Fe2O3 will find out. So I am writing the question here, 8th question, Fe2O3. So it is 2x plus 3 into minus 2 equal to 0. 2x minus 6 equal to 0. So x equal to plus 3. So what is the oxidation state of iron here? It is plus 3. Likewise, Fe3O4. So I will put 3x here plus 4 into minus 2 equal to 0. 3x is equal to 8, or x equal to plus 8 by 3. So what is the charge on iron? It is plus 8 by 3. Okay. Although we are going to discuss this fractional oxidation state separately. Okay. Now the 10th is AlOH whole 3. So I have to put this as x plus. Now I know that OH is an ion, and what is the charge on OH? It is minus 1. So 3 into minus 1 equal to 0. So x equal to plus 3. So what I will do, there are few ions, okay, which have total charge. So I will learn them. Like OH is having minus 1 charge, SO4 is having 2 minus charge, PO4 is having 3 minus charge. It is sulfate, it is phosphate, this is carbonate ion, this is ammonium ion. Okay, so there are few ions whose total charge we can count. Cn has minus 1 ion charge. Okay, so I will use this knowledge. Suppose if the question is find out the oxidation state of sulfur here. Now what I will do, I will use the knowledge of NH4. Now NH4 is having plus 1 charge, so 2 into plus 1. Now sulfur is x plus 4 into minus 2 equal to 0. So 2 plus x minus 8 equal to 0, or x equal to plus 6. Okay, so there are certain molecules which involve ions. Okay, suppose if the question is calculate the oxidation state of this compound, iron. So iron is x now. Now it is Cn6. So 6 into minus 1, because cyanide is having minus 1 charge, it is equal to minus 4. So x equal to plus 2. So this way we can find out the oxidation state of any element which is given to us. Now, based on the concept of oxidation number, now how we can define redox reaction? So oxidation means there is increase in the oxidation number. Okay. So we will find oxidation number of all the elements and then we'll see whether it is increasing. Likewise, reduction means there is decrease in oxidation number. Okay. Now again, the concept of increase and decrease should be clear, that if you are moving to the right of your number line, it is increasing, and to the left, it is decreasing. So we'll take one reaction here. Suppose this reaction is given to me and I have to find out that which substance is oxidizing and which substance is reducing. So I will find out the oxidation number of all the elements. Okay. So here I will find of manganese, because oxygen I already know it is -2. So X plus number of oxygen atoms are 4. Charge on one oxygen atom is -2 equal to -1. X -8 equal to -1. So X equal to +7. Here, what is the charge on Br minus? It is -1. Here it is +2. It is already given. And here bromine is present in the elemental state. So what is the charge on bromine? It is 0, not 1. Okay. Now you can see that +7 to +2. Okay, it is decreasing. So decreasing means it is reduction, and -1 to 0, it is increasing, that is, it is oxidation. Okay, so whenever any reaction is given to us, we'll find out the increase and decrease in oxidation number. Okay, and then we can find out whether it is oxidation or reduction. Likewise, one more example we can take. Such equations are ionic equations, okay, which involve ions. Now we will find out the oxidation number of all the elements. Here I will find of chromium, because here also chromium and here also chromium. So you have to select the same element on both the sides. So 2x plus 7 into -2 equal to -2. So 2x minus 14 equal to -2. So x equal to +6. So what is the oxidation state of chromium? It is +6. The oxidation state of iron is +2. Here chromium is +3 and here iron is +3. +6 to +3 decrease, that is reduction, and +2 to +3 increase, it is oxidation. Okay. So this is how we can easily find out oxidation and reduction if any equation is given to us, whether it is molecular equation or it is ionic equation. Okay. Now our ultimate purpose of learning the oxidation number is to balance the equation. Now we will be balancing such type of ionic equations. Now we'll discuss types of redox reactions, and the first is combination reaction. Now what is the meaning of combination reaction? Two or more substances combine to form a single molecule. And now we'll find out that combination reactions are also redox reaction. A very good example of combination reaction is this. This is a very simple reaction. C plus O2 gives CO2. So here the oxidation state of carbon is 0. Here it is also 0. Now here we'll find out the oxidation state of carbon. So x plus 2 into -2 equal to 0. So x equal to +4. So carbon is +4, and what about oxygen? It is -2. So now 0 to +4, it is increasing, so it is oxidation, and 0 to -2, it is decreasing, so it is reduction. So combination reactions are also basically a type of redox reaction only. Okay, means we can say that if any reaction is taking place, definitely oxidation and reduction is also taking place. Okay. Now next is decomposition reaction. Decomposition reaction means a compound breaks into two or more simple molecules. For example, NaH gives Na plus H2. Now the oxidation state of sodium is +1, hydrogen is -1 here, we already know. Now here sodium is 0 and hydrogen is 0. So you can see that +1 to 0, it is decreasing, reduction, and -1 to 0, it is increasing, that is oxidation. So decomposition reactions are also a type of redox reactions. Next is displacement reaction. Now we'll take the example. Okay, this is a very simple example. You know the meaning of displacement. Displacement means one atom is replaced by another atom or group. Okay, generally more reactive displaces less reactive. Displacement can be single also and displacement can be double also. Now what is the oxidation state of zinc here? 0. Here copper 0. Now here we will find out of zinc. Now we know that sulfate has -2 charge. So copper is +2. Here sulfate has -2, so zinc is +2. Now 0 to +2 increasing, it is oxidation, and +2 to 0 it is decreasing, it is reduction. So displacement reactions also involve redox change in them. Now the last type is disproportionation reaction. Now this is a new type of reaction which we have not learnt in class 10th. Now what is the meaning of disproportionation reaction? Disproportionation reactions are those in which a same element is simultaneously oxidized and reduced. Means one element will be oxidized and one element will be reduced simultaneously. Now we'll take one example here. For example, okay, so we'll find out the oxidation state of phosphorus. Here phosphorus is 0 because it is the elemental state. Here the oxidation state of phosphorus is x plus 3 equal to 0. So x equal to -3. Here +2 plus x -4 equal to -1. X -2 equal to -1. So x equal to +1. So here the oxidation state of phosphorus is +1. Okay. So I will write here. So now 0 to -3. Okay. It is decreasing. So it is reduction. And here 0 to +1. It is increasing. So it is oxidation. Okay. Okay. So 0 to +1, it is increasing. So it is oxidation. Clear? So such reactions are known as disproportionation reactions. Okay. The same element is phosphorus is reduced as well as oxidized simultaneously. So these are the types of redox reactions, 4 important types. So we can see that whenever any chemical reaction is taking place, whether it is combination, decomposition, displacement or any other type, there is always a redox change which is taking place in the reaction. We can write any chemical equation and then after observing the change in the charge or the oxidation state of the element, we can say that this particular reaction is also a redox reaction. Or in a simple language, all chemical reactions are redox reactions only.